Hi guys, in this video we're going to talk about linear law. Now, linear law is a method that we use to find a relationship between two variables, right? Now, basically linear law means we're using the equation straight line y equals mx plus c. So in this recording, we're going to focus on conversion of non-linear to linear form. So for example, why do we use linear law? Okay, so a classic example would be, let's say you have an experimental value of x and y, and you know that the relationship between x and y are given by, let's say, y equals to ax squared plus bx. Then we can actually calculate, maybe your experimental value, you got your x value and y value, and you draw a graph, and then from the graph you may find that your graph may look something like this. It's a curve, right? It's a quadratic. Yep. So now obviously it's a bit difficult to find the values of unknown a and b from the quadratic graph because it's a curve, and we know the gradient of curve changes throughout the whole curve. So rather than plotting y versus x, what we can do is we take this equation and we divide it by x. So as I divide by x, I get y over x now. This is now ax plus b. So we treat this like a big Y. This will be a gradient, this will be a x, this will be a c. So that is, instead of plotting y versus x, I plot y over x versus x. So I take the table values here, I recalculate the value of y over x here, and then from there I'm going to draw y over x as on my y-axis, x on my x-axis, and I plot the points. I'll get a straight line. Now, you already know this line is called the line of best fit. Line of best fit is a line that passes through as many points as possible, and it's balanced. For example, if you have 2 points above, then you must, as much as possible, we must have 2 points below. Okay, so now what can we get from line of best fit? We can find two things. We can find the gradient, and in this case, let's say your gradient is half. You can compare with the gradient that you have in your equation, which is a, so we can know that a is half. And then we can also find a y-intercept. Let's say my y-intercept is 3, and we can compare the y-intercept that we have from the equation here, which is b. So therefore we can conclude that b is 3. Okay, so we know we can convert nonlinear to linear form, but the thing is, how do you know what to do? For example, in this case, I divide by x. Can we times y? Can we divide by square root x? Can we multiply by x? Okay, so there are some guidelines actually to know what to do to convert non-linear to linear form. Number one, the first one is your big Y. Your big Y is usually a variable in terms of x or y, okay, or x and y, sorry, or just y. Okay, example, your big Y can be xy, x over y, y root x, or just single y square, 1 over y, square root y, and so forth. Now, the coefficient, you cannot have any coefficient y. There's no coefficient y. So any number in front of y, or the constant in front of y, we need to rearrange it. For example, let's say you may have a y squared equals to bx plus 1. So in this case, this number a constant, we're going to divide it by a here and bring it over. Okay, next, how about x? X is usually in terms of x only. Example, you may have your big X to be x squared, 1 over x root x. By the way, just to clarify, when I say big Y, big X, I'm referring to the variable on the y-axis and the variable on the x-axis. So this is your y-axis, let's say it can be y squared, xy, or so forth. Big X variable on x-axis can be x squared, 1 over x, and so forth. Now, the coefficient of x is your gradient. So in the event that you have any coefficient x like this, we need to separate them so that this is your big Y, this is now your gradient, this is now your x, and your c. And finally, c should be a constant. Yeah, or should I say no variable x and y, or y. So for example, you may have y equals to let's say ax plus b over x. So you notice this is your mx and c. Let's say you cannot have a c with the x, so we have to multiply everybody by x. So xy is now ax squared plus b. Now this is your big Y, this is your gradient, the big X is x squared, and this will be your C, right? So these are some basic guidelines that we should know. Okay, moving on. So I'll give you some example, like how do you convert non-linear to linear. Maybe you start off with a simple one. Okay, let's say xy minus, should I say plus ax equals to b. So this is a very simple one. The operation that you have to use is usually plus, minus, times, divide, square root, or even inverting. Inverting means 1 over, yeah, invert. Okay, so this is a simple example. Just transfer over xy will be what? Negative ax plus b. So this is your big Y, this is your gradient, this is your x, and this is your c. Now sometimes you may have to square root. For example, you may have y, let's say minus a, let me make it py minus q square equals to, let's say, x. So in this case, I just bring over, square root it, transfer the q over, becomes plus q, then you divide by p. So this is 1 over p root x plus q over p. So this is your big Y, this is your gradient, this is your x, and your c. So notice that the operation is a bit more. You got to square and transfer over and also divide. Now why your p has to divide here? Because why you have to divide p? Because coefficient of y must be 1. You cannot have any number in front, right? So you got to transfer any constant in front. Okay, another example would be involving inverting. Let's say you may have y equals to ax over x plus b. Now in this case, you notice that you cannot separate the denominator. Yeah, mathematically speaking, we know like 1 over 2 plus 3, you cannot break up to 1 over 2 plus 1 over 3. We know this is wrong, but 2 plus 3 over 5, we can say it is 2 over 5 plus 3 over 5, right? So we need to break this up, because in order to convert to y equals mx plus c, you must have two terms on the right separated by the plus sign. So what we can do is we can invert this. When I write y, it means y over 1. So when you invert it, it becomes 1 over y. And this is x plus b over ax. When we separate them, you get x over ax plus b over ax. What we can do, we can cancel them. The b over a we can write on the left, and we write this as 1 over x. Keep the 1 over a on the right. Yeah, switch this over on the right. So this is your big Y, this is your gradient, this is your x, and your c. Alright, so this is some example that we can use, right, to convert non-linear to linear form. Okay, let's move on to the next one. Okay, so the next part, in the classic example, yeah, classic exam question, you can see, is that they give us a graph. Let's say the graph like this, and let's say the equation is I'll just use root y and say 1 over x. Let's say it passes through minus 6 and 3. So, and it asks us to express y in terms of x. So one thing, when you're given coordinates, yeah, we can find the gradient and y-intercept. Remember, bottom line is for linear law, we want to form equation straight line, right? So we can find gradient by using negative y-intercept over x-intercept. In this case is half. I can find my y-intercept. My y-intercept is 3. Now, you know equation straight line is y equals mx plus c. My gradient is half. My y-intercept is 3. But if I want to find y in terms of x, I need to replace your big Y. Remember, big Y is a variable on your y-axis with root y. Replace my big X with, in this case, 1 over x, right? So we can write this as 1 over 2x plus 3. And to make y as a subject, I just basically square them, right? So you get y equals 1 over 2x plus 3 bracket square. Okay, so this is one example. So another example I can give you is this. So sometimes you may be given a point, let's say like this. I'm just going to use random number, say 1, 5, 3, and 11. So let's say this is x, y, and let's say this is x squared. And sometimes they will even give you the equation of the straight line. So it's a equation of the curve. This is a non-linear function. See, non-linear, we can say equation of curve. Yeah. So you want to use either convert from non-linear to linear or linear to non-linear. But irregardless, you need to find two things from the graph. You always have to find the gradient and the y-intercept. Now, so let's say I start by finding the gradient. 11 minus 5 over 3 minus 1, I'll get 6 over 2, which is 3. To find my y-intercept, I like to use y minus y1 equals to mx minus x1. Now my x1, y1 will be the 2 points here. Now take note that I always use capital Y, capital X, because capital Y represent, remember what I say, the variable here, capital X represent the variable here. You want to avoid using small y, and then you replace the small y with this xy. It looks very confusing. Yeah, you confuse yourself, right? And even the examiner. So your y1 will be, in this case, 5. Your gradient is now 3. My x1 is now 1. So y is now 3x minus 3 plus 5. Your y is 3x plus 2. Now, here, from here on, we have two methods. Method 1, we start from the linear, we work towards the non-linear. Now, your linear is this, y equals mx plus c, right? Your big Y is now xy. Your big X is now x squared plus 2. So, remember, our goal is to find the value of unknown a and b. Usually, they give you the non-linear function, they put unknown inside, and you're supposed to find the values of unknown. So what I can do is I make y as a subject, like how I did the previous example. Divide everybody by x, 3x plus 2 over x. And you can copy the non-linear function here and compare directly. Yeah? By comparison, we know a is 3, b is 2. Yeah, coefficient of x, you compare coefficient x. Coefficient of 1 of x, you compare with coefficient of x. You get a equals 3, b equals 2. Now, some people may prefer to start from non-linear to linear form. Okay, now non-linear in this case is your ax plus b over x. So to convert to linear form, what we can do is we can multiply by x. I know you may be thinking, how do I know what should I do? Well, you look at the graph. If they give us on the graph your y-axis is xy, so we know we have to multiply by x. So I can get this variable here, this big Y here. This is now ax squared plus b. Now validate, your big X is now x squared. So this is your big Y, this is your gradient, this is your x, and your c. So by plotting xy versus x squared, I'll get a straight line. So let's find out, what is the gradient from the graph? Well, my gradient is 3. By comparing my gradient from the graph with the gradient from the equation here, the gradient from the equation is a, the gradient from the graph is 3, so a is 3. Let us compare the y-intercept. The y-intercept from the equation is b. The y-intercept from the graph here, see, y equals mx plus c is 2, so b is 2. Notice that the answer are the same. Now you need to know both methods, linear to non-linear and even non-linear to linear, because depending on the type of question is given. Now the previous example, they don't give us the equation, the non-linear equation. So you need to start from linear, work towards the non-linear by making y as a subject. In this question, you can do both, right? But for the next question, okay, I'll give you another example. Okay, so let's say I have a point minus 1h. All right, this is x over y. This is k1, let's say, and this is x. Let's say you have an equation like this. For the next question, they will have to give you equation of a curve. Let's say my equation of curve is x over 3 minus x. Yeah, or equation, the non-linear equation. In this case, you have no choice but to start from non-linear equation. Why? If you try to start from the graph, you're going to find the gradient. What's the gradient? h minus 1 over minus 1 minus k. Can you find your gradient? Oh, in fact, you have two unknown, right? It'll be very difficult. You try to find a y-intercept, y minus y1. Let's say I use this point here, equals to m, h minus 1 over minus 1 minus k, x minus x1. Now, how are you going to even find c? And even if you try, your c will be in terms of h and k. It will be a very complicated equation. So we cannot start from the straight line now. So what we have to do is we have to start from the non-linear function given here. Now again, what to do depends on what you're given here. Now take note, your big Y is now xy. So what we can do is we can switch, or some people may say invert. Switching means I bring the y down. I bring the 3 minus x up. I do it in one step, x over y. and I will rearrange it. I can see this now my big Y, this is now my gradient, this is now my X, and this is my C. So my Y is basically negative X plus 3, right? So this is my linear form. Now, in this case, we cannot compare the gradient. Why? Because if we try to compare the gradient, my gradient, okay, some people may say, okay, my gradient is -1, this is equals to -1. Now you try to solve it, you cannot solve it because you have two unknown. And remember, your y-intercept will be a very complicated equation, although this can be done, but I don't think you want to do it, because if you times inside, guys, this will be k with a h minus 1, 1 minus k, sorry, 1 plus k plus 1. This is so complicated. How are you going to do that, right? So what we do instead, we use substitution. Now, substitution means we sub -1h. My big Y is h. My big X is -1. And I can solve for h is 4. If I want to find k, I sub k and 1. My big Y is 1. My X is k. My k is 2. In this manner, it is much easier, right? You can find the values of unknown from the coordinate. Yeah. Okay.